Today's our second day of review to get us prepared for our final, and today we're going to be reviewing everything radical and square roots related. So all operations, including addition, subtraction, multiplication, and division, and just how to simplify them so that they're in what we call simplest radical form. So example number 1 says, perform the indicated operations and express the answer in simplest radical form. We haven't necessarily seen it worded like this, where it says simplest radical form. That just means that at the end, your answer has to be simplified all the way through. Meaning if I get radical, 72 as my answer, that's not in simplest radical form, because I can still look for a perfect square that fits into that number. Okay, so when it asks you for simplest radical form, it just means that your answer has to be simplified all the way through. Your answer cannot be broken up any longer. That's when it's in simplest form. So we have 3 radical 7 times the square root of 14 plus 4 the square root of 56. Okay, so the first thing that we're going to do here is anytime you see a problem and you see parentheses, the first thing that you always want to do is get rid of that parentheses by distribution. Okay, there's no other way that you can get rid of this parentheses unless you take what's outside of the parentheses and you distribute it to everything that's inside. So I'm going to take this 3 radical 7 and I'm going to distribute it to this square root of 14. And distribution is always multiplication. So I have 3 square root of 7 times the square root of 14. Okay, then I'm going to take that same 3 radical 7 and I'm going to distribute it to this positive 4 radical 56. Now, one common mistake that I've been seeing in some students' problem is that you're forgetting this plus sign, and that plus sign is very important. Okay, if there's a plus sign there, that means you need to bring that plus sign down into your problem. So I'm going to put plus, and now I'm going to go ahead and multiply 3 radical 7 times 4 radical 56. Okay, I can't just write these two things separately without anything in between like this, because it just doesn't make any sense, and then second, you're not telling me what operation is happening between these two things. So I need to have that plus sign or minus sign, depending on what's in between those two terms. Okay, so now I'm gonna go ahead and add ones wherever there's none, just so it could help me out. And I'm gonna go ahead and multiply these two pieces separately. Okay, I'm not multiplying 3 radical 7 times all of this all at once. Okay, I'm multiplying this first, and then once I'm done with that, I can go ahead and multiply this right after. So first I want to multiply what's in the red. So I have 3 times 1, and then I have radical 7 times radical 14. So when I do that, 3 times 1 gives me 3, and radical 7 times 14 gives me square root of 98. Okay, now that I've done that, I'm going to go ahead and do the orange piece. So I have plus 3 times 4 times radical 7 and square root of 56. I just rearranged everything so that the radicals are with the radicals and the numbers outside the radicals are with each other. So now I have positive 3 times 4, which gives me a positive 12. So if it's a positive, I have to include that plus sign. If it gives me a negative, then I have to include the negative sign. So I have positive 12, and then I have 7 times 56, which gives me the square root of 392. Okay, so I've multiplied everything out, and I've gotten 3 square root of 98 plus 12 times the square root of 392. Okay, now however, if we go back to the example, the question in the example, it says that it has to be in simplest radical form, which means that I still have to go into these radicals, and now I have to figure out, okay, how do I simplify these numbers inside of the radicals? How can I break this up using the perfect squares that we have on this table? and we're gonna again do that one piece at a time. I cannot simplify two things at a time. I also can't combine these two things because 98 and 392 are not the same numbers. So I can't just say this is not equal to just let's say 15 plus the square root of 490. This is completely wrong. I can't just go ahead and add those two things because the 98 and the 392 do not let me do that. In order for me to combine, what's inside of the radical has to be the same for both things. So I have 3 square root of 98 plus 12 square root of 392. So first I'm going to deal with the, let me just rewrite this so it's perfectly clear. I have 398 plus 12, 392. So first thing I'm going to do is I'm going to work with my 3 square root of 98. Again, I'm going to do these two things separately. So I'm going to go into my table and I'm going to check what is the biggest perfect square in this table that I can divide 98 by without giving me a decimal. Okay? And if we go through our table, the biggest perfect square that actually fits into 98 is 49, because 98 divided by 49 gives me 2. So I can break this up into 3 times 49 times 2. Okay, because 49 is the biggest perfect square that goes into 98. And I ask myself, okay, 49 times what will give me 98? And that will be 2, because 49 times 2 gives me 98. So I broke up my 98 into 49 and 2. And now I can break these up into two separate pieces. I have 3 times the square root of 49 times the square root of 2. Okay, but I know that 49 is the perfect square because that's the number that I got from my table. So that I can say the square root of 49 then is equal to 7, which means my radical disappears. And one common mistake that I've seen is some people say, okay, 49 is the perfect square, so I'm just going to write 3 times 49 times the square root of 2. That's completely wrong. Okay, if 49 is your perfect square, then you go into your table, you check, okay, the square root of 49 is actually equal to 7. So I can simplify this as 3 times 7 times the square root of 2. And that turns into 21 times the square root of 2. Now I can go ahead and simplify my right hand side. So now I have 12 times the square root of 392. So again, I'm going to go into my table and I'm going to check what's the biggest perfect square that I can divide 392 by. And after checking, I know that the biggest perfect square that goes into 392 is actually 196. So I can break this up into 12 times 196, and I ask myself, okay, 196 times what gives me 392, and it's actually 2 as well, because 196 times 2 gives me 392. And remember to always bring your plus sign down, okay? You cannot just disappear what's in between the two terms that you're simplifying. There's always has to be, if you have two terms, as you're simplifying, there should be a plus or a minus sign there, depending on what happens as you go on forward. So now, again, I break this up into 12 times 196 times 2, square root of 2 and square root of 196. And again, I can't just take this 196 out of the square root and just write that again. I go into my table and I know that the square root of 196 is actually equal to 14. So I can rewrite this as 12 times 14 times the square root of 2. And that gives me 12 times 14 gives me 168 square root of 2. So if this and this were two different numbers, then technically our job would be done there. But because we have two terms which both have a square root of 2 with them, meaning they both have the same, if we call it, if we're going back to combining like terms, we call it that they have the same last name, right? They both have a square root of 2. That means that we can actually take one further step to simplify this problem. Since these two both share the same radical, they both share the same number under the square root, that means that I can do 21 plus 168 to give me 189 times the square root of 2. All I did was add the numbers outside of the radicals, 21 plus 168, to give me 189, and I kept the radical 2. And that is only because both of them have square root of 2. If this would have been, for example, 21 square root of 2 plus 168 square root of 3, because these two numbers are different, then our answer would just be this right here, because we can't combine anything else. However, if there's anything in your answer that shares the same square root, that has the same number under the radical, then you can always just combine them just like you would with combining like terms. So in example number 1, this expression expressed in simplest radical form is 189. It's 189 square root of 2. Okay? So now in example 2, it says divide the answer that you get in example 1. So take 189 square root of 2 and divide it by 9 square root of 2. So now we're dividing. In the top problem, we did a lot of multiplication, and addition. In this one, we're going to go ahead and divide. Okay, so I can divide what's outside of my radicals. I have 189 divided by 9, which gives me 21. And then I have radical 2 divided by radical 2. Well, 2 divided by 2 is just 1. So I can technically just write 21 times 1. Some other students have been writing the square root of 1. But if I go in my table, I also know that that's just equal to 1. So this is equal to 21 times 1, which is just simply 21. Okay, and I show you this example just to show you that sometimes it's okay when your radicals disappear. You can't just make them disappear however you want to. They disappear when whatever's inside of here is a perfect square, just like 1 is a perfect square, so that just turns into 1 when you square root it. Okay, so the answer to example number 2 is just simply 21.